All right, so yesterday you guys learned a new way of solving quadratics when they're in this form. And remember that when you're solving a quadratic, it really is almost the same thing as just solving an equation. You're just trying to figure out what x is. And so before, when you learned how to solve these, the only way you knew how to do it was to factor this, to break it into its factors, right? To get two binomials and to set each one of those factors equal to 0 and then figure out what x is that way. Yesterday, though, you learned that if you just set this whole thing equal to 0 and rearranged it so that you got the x squared by itself, that you could then just take the square root and figure out what x is that way pretty simply. And especially if what you ended up with on the end was a perfect square, then it's really easy to work with. So today, what you are focusing on is to be able to solve a quadratic when it's in this form, this x squared plus bx. And we know that it gets a little bit trickier when we have this middle term here. Typically, these are pretty easy to work with, but this can be a little bit harder because it's hard to break this into its factors, right? Like if I were going to factor this into two binomials, it's tough to think about what would multiply together that leaves you with no end term, but it does have a middle term. So there's something that you can do to make that a little bit easier on yourself in order to be able to solve for x, which is our goal, right? And that's called completing the square. So that's your goal for today, is to be able to solve quadratics by completing the square. And what you do with that basically is that since this is hard to factor, it's a lot easier to factor if you had a term at the end. You guys know how to factor trinomials really well, especially if this were a perfect square trinomial, meaning this is a perfect square because it's x squared, x times x is x squared, and if c is a perfect square, because you could then use patterns to be able to figure that out really simply. So that's what we're working on today. What you can do when it's just in this form is you tack on a constant at the end that will make this a perfect square trinomial. But you can't just tack on any number that you want. There's a method to your madness to be able to do that. So what you do is basically you take the patterns and then undo it. So you would have to, in order for this to be a perfect square, it would have to be half of whatever b is and then squared, right, in order for that to make sense. And then you would tack that on at the end in order to get it there. So once you've done that, then you can factor this as a perfect square binomial. So let me show you what I mean with that. Here are our steps. If this asks me to complete the square, what I want to do to get this to be a perfect square trinomial would mean that I have to, c would have to be half of b squared. So this is my b. So half of 6 divided by 2 is 3. And then square it. So 3 squared is 9. Then you tack that on at the end as your c. You add it to the end. So you would add 9, right? So I'm left with x squared plus 6x plus 9. That's really easy to factor because it's a perfect square trinomial. I can just use my patterns. I know x squared is a perfect square and 9 is a perfect square. And I have two addition signs in between. So that's going to leave me with the binomial x plus 3 squared, right? Because if that really undone would be like x plus 3 times x plus 3. And then when you've distributed that and you got it back to its original form, this is what you would end up with. So your final answer, if you're just asked to complete the square and then factor it, would be x plus 3 squared. Okay, let's try a second example. Complete the square. So I would have to find half of b. So half of negative 9 is negative 9 halves. And then square that. So negative 9 halves squared is going to be 81 over 4. And I'm leaving it as that improper fraction because they're both perfect squares, which makes it easier on me. So then I would tack that on at the end, 81 fourths. Now I have something that's a little bit easier to factor because this is a perfect square and this is a perfect square. So if I were going to factor this trinomial now, what I'd end up with is x minus 9 halves squared. And then that's your final answer there.